You're listening to Science, Powering Tomorrow, the GNS Science podcast that demystifies complex science concepts and shines a light on its critical and very cool groundbreaking science. Some of my best friends are scientists, and here at GNS, there are endless stories to tell and fascinating people to meet. I'm your host, Dr. Mary Ann Clive, a hazard and risk management scientist with GNS. I am so pleased to have you join me on our storytelling adventures as we dive deep into the science and innovation produced right here at GNS. Together, we'll learn about the critical impact of that cool work and how it is improving our lives and livelihoods every single day. So let's go. It's time to get inspired by science. Today we're talking risk, and specifically RiskScape, with Dr. Nick Horspool. Welcome, Nick.
Hi, Marianne. Thanks for having me on today.
So can you tell us a little bit about what it is you do at GNS Science?
Yeah, sure. So I'm what's called a risk scientist. So I like to understand the risks posed by natural hazards and climate change on parts of communities. So what is the risk to people, to buildings, to our infrastructure, and try to use that information to help avoid the impacts of natural hazards on our communities and reduce those down to a tolerable level. So trying to help people in communities, whether that's the public or infrastructure owners or building owners, to understand those risks and what actions they can take to reduce them.
Okay. So there's a supercomputer calculating our nation's risk, and it's called RiskScape. Using leading tech, the RiskScape supercomputer is humming away, crunching data and scenarios every second. It can tell us which roads are likely to close following an alpine fault earthquake, whether volcanic ash will land on your roof, and even whether a seawall will protect your community from tsunami and coastal erosion. And I understand you have a lot to do with RiskScape, Nick. We often talk about New Zealand's unique place on the Earth's surface. It's positioned along the collision zone of two of the Earth's major tectonic plates, the Pacific Plate and the Australian Plate. These forces that have created our dramatic and beautiful landscapes here also make New Zealand extremely prone to natural hazards. Typically, we look to insurance to manage this risk, Nick, but we're seeing insurance costs on the rise. What do we do about this?
Yeah, good question. So New Zealand, we are exposed to every risk under the sun. So every hazard that's, across the globe, we have that in New Zealand. So we're a really risky place, but we don't have to accept that risk. There's lots of things that we can do to reduce that risk and reduce the impact from natural hazards. Insurance is one of those. So insurance is where you pay a company a certain amount a year, and they then cover the damage and loss when your house or your contents or your car are damaged by natural hazards. But there's lots of other ways that we can actually reduce risk as well. So we can choose to avoid that risk. So we can do things like not build in risky locations, like on a coastal area that might be prone to sea level rise, for example, or coastal inundation. We can mitigate the risk. And when I mean mitigate, I mean things like we can reduce our vulnerability to natural hazards. So we can do things like if we have a chimney on our house that might fall in an earthquake and cause damage to our house, we could remove that chimney. We can choose to accept the risk if it's at an acceptable level. If we might be in a flood zone, we might be willing to accept that we're in a flood zone if it's only relatively low level flood, for example. And we can also then transfer that risk through things like insurance. So insurance is one of those ways that we can mitigate risk, but it's not the only solution.
And so when you're talking about risk transfer, how would you describe risk transfer?
Sure. So if there was a damaging natural hazard like an earthquake, if we didn't have insurance, we would have to pay for the repairs ourselves. So instead, we transfer that risk to an insurance company, and they will then cover the damage and losses, but we have to pay them a premium to do that. New Zealand is actually one of the most insured countries in the world. We have really high insurance penetration across residential buildings, and we have the Natural Hazards Commission, which was formerly called the Earthquake Commission, to thank for that. So following a series of earthquakes in the 1940s in the Wairarapa, they decided to take a little bit of money from certain levy from taxpayers and put that into a fund called the Natural Disaster Fund that builds up year on year, so that when a big disaster happens, they can cover the cost of that for residential building owners. So they cover the first $300,000 of damage to your property for things like landslides, earthquake, tsunamis, and volcanic eruptions.
So you are a risk scientist, Nick. What got you down this path?
Yeah, so I grew up in the North Shore of Auckland, Marianne, and went to a school called Rangitoto College, which sit up on top of a hill and wasn't on Rangitoto Island, but looked out over Rangitoto Island. And so for those who don't know, Rangitoto Island's a volcano that was the last one to erupt in the Auckland volcanic field. So I always had my eye on this volcano and just loved the look of it. When I was in sort of senior years of high school, I really was enjoying geography and social sciences. So at university, I decided to take earth science and always thought that, volcanoes were my thing. But then I took a little bit of a sidestep away from volcanoes and became a bit more interested in earthquakes, which we don't actually have in Auckland. And so after finishing an earth science degree at the University of Auckland, I came down to Wellington, where we are now, and studied earthquakes, more specifically using earthquakes to understand the structure of the Earth's crust. But as I was doing this research, I was a bit more interested in, the impacts of earthquakes. And so I migrated into understanding the hazard from earthquakes. And then that sort of started off my journey into understanding natural hazards, both from how they occur and the impacts on communities. Before working at GNS, I actually worked in Australia for an organisation called Geoscience Australia, which is a government research organisation over there. And I was working with scientists in Indonesia and Papua New Guinea to collaborate on natural hazards in the Asia-Pacific region. And then about 10 years ago, moved back to New Zealand and came full circle back to Wellington.
Back to the shaky isles and the earthquakes and volcanoes of Aotearoa. That's great. And so can you tell us about RiskScape and what part RiskScape plays in this scheme?
Sure. So RiskScape is our supercomputer that we use to calculate the impacts of natural hazards on communities. So it's a computer model, and when I mean model, I don't mean like a fashion model. A computer model is like a simulation in a computer. A little bit like something like SimCity, if you've ever played that game. And so what we can do in RiskScape is we can simulate the impact of natural hazards on different parts of our community. So that could be buildings or people, infrastructure or horticulture or agriculture. And we can quantify those impacts in terms of the numbers of people that might be injured or killed, the damage to buildings, the outage to infrastructure, and where the crops and the like will be damaged. So we can do that to understand the level of impact for different hazards, and we can develop scenarios on that. But what's really cool is we can start asking questions, what if? We don't have to accept the level of impact. We can say, what if we build a higher stop bank? Or what if we built our buildings stronger? And what if we build an extra water pipe for this community? And we can then see how we can reduce those impacts all through a computer simulation without having to do it in real life. And we can then identify what are those mitigations that are most optimal for different communities and different situations. And we work in collaboration with local government, central government, and communities to help them identify ways that they can reduce their risk through this computer simulation.
Wow. It's a complex SimCity.
It is.
So how do the simulations work? What goes into the simulations?
It's really data intensive. So we need lots of different information on natural hazards. So we work with scientists across New Zealand to help us understand hazards. So that's like where a tsunami may inundate, or where a flood may occur, or what the shaking might be from an earthquake, or the thickness of volcanic ash for an eruption. We then bring in elements of our community that we're interested in, and that might be location of buildings and its attributes. So things like, is it a one-story building? Is it made of brick or timber? And then we have other elements that represent the vulnerability of those things. So We know that brick buildings are more vulnerable to earthquakes, and so we have mathematical models that reflect that. And the way that we develop those is that whenever there's a natural hazard or a disaster that occurs, we send teams out and we go and map the damage from those events. And we do this in New Zealand, and we also do it globally. So, for example, we've had people go to Japan in 2011 to look at the impacts of the tsunami over there. We've had volcanologists go to South America and Indonesia and look at the damage to buildings and infrastructure from volcanic eruptions. And recent flooding events in New Zealand, we've had scientists go out and look at the damage to buildings and roads from floods and landslides as well. And we use all that information, and that goes into this big melting pot of RiskScape, and it then is used to understand those impacts.
So it sounds like a lot of people have been involved in pulling all of this information together that goes into the simulations.
Yeah, we've been developing RiskScape for about 20 years now, and we've got a wide range of disciplines involved in the RiskScape team. We have hazard scientists from GNS and NIWA and universities across New Zealand. We have engineers that work at GNS and universities that we collaborate with. We have computational scientists that help us develop the computer code. We work with a company called Catalyst IT, and they're the main software developers. They've got a whole lot of tech people who help us develop the computer code. And we work with social scientists as well, much like yourself, Marianne. Mm-hmm. And they help us translate that information for people who might like to use it to make those decisions at the end.
Amazing. So who are those decision makers who are going to be using RiskScape to make decisions at the end? Who's a typical user, and why might they find it helpful?
Probably our biggest user is local government, so councils. So they're responsible for making a lot of decisions around natural hazards. So they have to decide where we build, where we develop areas. So land use planning is a really big application. So what we can do with RiskScape is we can show local councils where are the risky areas that they might want to either avoid from developing or might want to implement regulations such as raising floor levels above a flood height, for example. So that's a big user. We also work with emergency managers, and this is in central government or local government, and we help them develop scenarios that they can plan for responding and managing natural hazard events. So with emergency managers, we might have a large earthquake scenario, and we might show them the areas that are more likely to be damaged, where people might be injured, and what the infrastructure status might be, whether there's blocked roads and so forth. And they'll use that information to help develop their scenario plans for response. We also work with asset owners that might be infrastructure companies like our water networks, and we help them understand the potential damage and losses from natural hazard events so they can go and get insurance as well. So quite a wide range of applications.
So you've discussed a lot of ways that we can use it to sort of play out what might happen and think about the future and how we might plan around it. Is there a way to use RiskScape to support some of the faster, rapid decision-making that needs to be done when something happens?
Yeah, so that's a really exciting area that we're starting to get into, which we call impact forecasting or early warning systems. So in that case, what we're doing is as an event's unfolding, or there's an event that might be coming, such as a cyclone or a storm, we can then use RiskScape to tell us what the impacts might be in real time. And we actually did that for ex-cyclone Gabrielle that came through the North Island in 2022. So as we saw in the weather forecast that Cyclone Gabrielle was coming towards New Zealand, we quickly got together our hazard scientists and our engineers, and we built a RiskScape model that would tell us what the impacts would be to the roading network, to the rail network, and to buildings across New Zealand. This information was used by the Natural Hazards Commission to understand what the level of claims might be for that, by organisations such as NZTA and councils to understand the roads that might be impacted by flooding or landslides. And what we did is we used the RiskScape model and we issued impact forecasts every 6 hours for the next 24 hours. So we were issuing these forecasts every 6 hours, providing updates, and that information was going into the situational awareness reports for these emergency managers.
Wow. And did you find after the event that they aligned pretty well? The impacts that you were forecasting, did they align with what happened?
Yeah, we were really happy with how RiskScape performed, particularly for the road impacts. We saw that the roads that we had forecast to be impacted the most were the ones that were, particularly by landslides. So the Brynderwyns, north of Auckland, the Coromandel Peninsula, and some roads on the east coast as well. So we're really happy with how the model performs. And it's something we do when we issue these forecasts. We always go back and look what happened and see if the model performed well, and then update it to make sure that we keep improving it over time.
Pretty exciting future for helping us respond to these events that seem to be happening, more intensely with our changing climate. So you've mentioned the Natural Hazards Commission a few times, and I understand you have a really strong relationship between RiskScape and the Natural Hazards Commission. Can you tell us a little bit more about the national loss modelling that's done with RiskScape?
Sure. So we actually have 4 partners in RiskScape. There's GNS Science and NIWA, who are the main developers. We have Catalyst IT, who I mentioned, to develop the software. And then we have the Natural Hazards Commission, which are a partner. So they help us fund the RiskScape development, but they're also using it internally for their own purposes. So we've helped them build their own custom model of RiskScape, which they use for estimating the numbers of claims that they may expect from different events. So they use that for helping planning their response, but they also use it in a post-event setting as well. So RiskScape tells them within minutes of an earthquake how many claims they might expect. So they know how many claims assessors would need to go out and the scale of the loss that might be expected. They also use it to forecast what losses might be occurring to buildings in New Zealand over the next few years to help them go and get reinsurance. So reinsurance is insurance on insurance. So they have the National Disaster Fund, which they pay out. But if the level of the event is more significant than what they have in terms of the funds available, then global reinsurers will help pay for that. And that's what we saw happen in the Christchurch earthquakes, where most of the loss was actually paid for by global reinsurance companies.
Interesting. It's really good to hear that level of investment and thinking ahead is going in. The Cyclone Gabriel was really a devastating event for New Zealanders, and anything we can do to try to understand what those impacts might be and how we can prepare for them and manage them and prioritize those resources to mitigate the impacts is fantastic. Do you have any other examples of some of the positive ways that RiskScape is having an impact?
So we're not only using RiskScape in New Zealand, we're actually using it in the Pacific as well. So NIWA and GNS have worked with different organisations in the Pacific to help them understand their risk and manage their risk as well by using RiskScape. We just finished up a recent project in Vanuatu where we developed a RiskScape model that estimated the impacts for Loganville, which is an area in Vanuatu. And so that looked at lots of different hazards from tsunami, earthquakes, volcanic eruption, flooding, coastal inundation, and helped the local government there to understand what their impacts are and to then manage those through different things such as insurance and mitigation of their key infrastructure. So we're translating some of the learnings we've had in New Zealand and helping our Pacific neighbours as well.
Oh, that's great. Is the risk environment quite different in some of these Pacific countries compared to New Zealand?
So they're exposed to all the same hazards we are. So we have what we learn here, we can translate over there, but we also go and understand what's happened over there in recent events and bring that knowledge back to New Zealand as well. So it goes both ways. In the Pacific, there's some of the buildings are more vulnerable due to the building codes not being the same standard and so forth. But there's a lot of synergies by working together with our Pacific neighbours.
Oh, that's great. we're almost out of time, but before we wrap up, I was hoping you could talk a little bit about what's next. It sounds like there's huge amounts of data, huge amounts of energy going into the supercomputer. What can our listeners expect to hear about next from the RiskScape project?
Yeah, so one area that I'm really excited about is trying to integrate AI or artificial intelligence with Riskcape. So some of our listeners might have used ChatGPT or other AI tools online to ask questions. We're now exploring how we can bring those into the Riskcape environment. And so what that might look like is, instead of a scientist like me having to develop a Riskcape model, someone in the public might be able to ask ChatGPT, what's my risk from flooding in 26 Beach Street, for example? And that would then build a Riskcape model, calculate the impact, and tell them the answer. So we're trying to see how we can use AI to help expand Riskcape to non-technical users, and hopefully it could just be integrated into some of these AI models where people can query Riskcape through those means. So that's a really exciting area, and I think it will really boost how we can get this risk information out into the hands of more people.
Wow, yeah, make it really accessible. I'm sure there's lots of people who'd be interested in being able to do that. Thanks so much for your time today, Nick.
Yeah, thanks for having me on, Marianne. It's been a real pleasure for letting me talk a little bit about Riskcape and share my passion for understanding the risk from natural hazards.
Well, look forward to hearing where it goes next. And thank you, listeners, for tuning in. Today's discussion is just the start. We have so many cool stories to tell here at GNS Science, so be sure to check back in on our podcasts. We are going to be delving deep into our natural hazards, our future energy solutions, the wonders of our environment, and the climate challenges we face. We'll be taking a look at the clever ways we dig deep and learn about New Zealand's past, and how that helps us forecast our future. Don't forget that you can keep up to date with all things GNS at gns.cri.nz or on all our social media channels. Join us in the next Science Powering Tomorrow episode. Thanks for listening.